Hi everyone, I hope all of you are doing well, and in this video I'm going to talk about how you should organize your Python files within the project that you work on. Now, I got a lot of comments lately of people asking me how they should manage their code in a Python project. So I feel like a video where I show you how I structure my Python files and giving you some examples along the way could be something very useful for you. So let's get started. Now, before we actually start giving some examples, I want to say that there is no standard rule of how a Python project should look like. It is really up to you where you want to locate your classes, your functions, your variables, and your if statements and your for loops. So by the end of this video, you can take a look in the description because I'm going to provide there some useful links from different people that have already created some templates and also some important information that I have found in the Python official documentation. Okay, so I'm already inside some random directory and I already came up with two templates that I want to show you throughout this video. So one of them will be inside a folder that I named it structure1 like that. Now one of the examples is going to be for more basic Python projects and the other one is going to be probably for some case where you want to create more complex and more advanced Python projects. Okay, so if I clean the screen here for a minute and then go with tree, then you can see that it shows us the structure of this directory in a nicer way. Okay, so you can see that inside here I have three files, and the first one will be run.py, and this file is mainly going to be saved for triggering minimal functions, and maybe you could add some sentence or two about what this file is responsible for, and this file is really going to be minimalistic. So I imagine this file only triggering one or two functions, but the really rest of the code and the rest of the actions that you want to take is going to be within helpers.py. So the helpers.py could be a file where you put in all the functions that you want to write, and then this run.py is going to import each function from the helpers.py. Now you could also name the helpers.py something like functions.py or actions.py, but something like that. But you mainly want to keep one file for triggering everything that you want to trigger, and as well as one more file for all of your functions. Now you can already pay attention for the constants.py as well. Now if you come from another programming language, basically a constant means a variable that is not going to change throughout the execution of your program. So what that means? It means that, for example, if you want to calculate all the prime numbers in a range of numbers from 1 to 100, then you probably want to store inside a constant.py two variables like start range and end range. So it is very important to understand that inside the constants there are always going to be variables that are not going to change throughout the execution of the program, and you are not going to override their values. Now, to really show you a basic project within this structure, I really want to develop a project where I calculate all the prime numbers between some given range of numbers. So let's go ahead and see an example of that in Python. Okay, so as you can see, I'm already inside this folder and I have already opened the run.py and as well as the other files. Now, as I said, in the run.py the code is going to be very minimalistic, and usually I go with that approach as well. So we could say here triggering the entire project, do this by Python run.py. Okay, so it is important to do something like that, and later on we are going to use some import statements, so it is a greater idea to move these comments out maybe 1 or 3 lines after that. Okay, so now we can basically go with something like def run. So we are creating a function of the lines that we want to execute, and in here we probably want to execute a function that we are going to name it later something like calculate primes, something like that, and we can already assume that this is going to receive a range of numbers. So we could say start equals to maybe 1 and finish equals to 100. Now you can already pay attention that we have some good candidates to store constants, because as you can see, those variables are never going to change throughout the execution of the program. So maybe you would want to go and store some constants inside your constants.py, and that will be by basically going to your constants.py and say something like start equals to 1 and finish equals to 100. Now actually there is a great reason that I capitalize each letter here, because it gives a cleaner look to our eyes when you want to see the reference to that variable. And as well as in most of the programming languages, if you have constants that are stored, in most of the cases you are going to see their name with all uppercase letters. Okay, so this is why I decided to go with that. And now I can go back to my run.py, and basically besides using those numbers hard-coded in here, I can go with something like the following. So I could say in the first line, import constants as const something like that, or as c, whatever you want, and we could say here c.start and in here c.finish. And so it really gives a cleaner look when you look in that way. Okay, so I know that we did not create anything about calculate primes yet, so we will create that in a second. And maybe we would like to store their results as a variable that we could name primes, and maybe we will want to print the results of that, so we could say print primes. Okay, so once you have this scenario, then it is a great idea to actually call this run function. Now, the way that you want to call this function is by wrapping this in a conditional that says if dunder name equals to dunder main, like that. And that will be double equal sign. Okay, so if you never saw me writing this conditional in here, then I have a video on that is quite explaining what is the purposes of writing this conditional. But basically this has happened to be a convention line of code in Python that checks if this file has run directly or has been imported, and we only want to execute this run function if we execute this directly by saying python run.py. So this is why I wrapped the call of this function within this conditional. Okay, so now we could go to helpers.py and really start creating some functions that will help us to calculate the prime numbers in a given range of numbers. So we could open our helpers.py, and we could also comment here something like functions that are going to help calculate prime numbers. And we did not comment anything in constants.py as well, so we could say here useful variables that are going to be used. Okay, so something like that could be fine. Okay, so inside the helpers.py we are going to write our functions. Now I'd really like to go with a function that first returns if the number is prime or not, and then later on we can write some other function that is probably going to calculate all the prime numbers in a given range of numbers. Okay, so we could first start with a function that says def is underscore prime, like that. And for sure this is going to receive the num as a parameter, so we want to receive one parameter at least. And now here we want to return true or false if the given number is prime number or not. Now, since in that video I'd really like to focus on the project structure itself and not on writing some algorithms for stuff like that, I'm going to paste the code snippet that is really responsible to return if the number is prime or not. And let me paste this in here, and I explain what is going on here. Now, first, I check if the given number is greater than 1, because I want to eliminate all the scenarios that the numbers are less than 1, meaning 1. So this is why I went with this if conditional in here. And later on, I check in the range of numbers between 2 to the given number if the remainder of such a division is not equal to 0. Now, if this would be actually equal to 0, then this already proves us that this number is not a prime number. So this is why I said here in the comment section, if the remainder is not equal to 0, then keep on checking, and I wrote this continue in here. And if we hit the else conditional in here, then it already means that we can return false, because if this division remainder is actually 0, then it means that it is not a prime number. And then later on, once we finish with this all for loop, then we can return true, because if the function never returns false, then it means that all the checks of the division has been completed successfully, and then we can allow ourselves to return true by the end of this function. Now, to actually verify ourselves in here for a second, we could basically print and call the is prime, and then we could try to test this with a number like 34, and obviously this is not a prime number. And then we could also test this with a number like 53, that I already know that this is a prime number. So now we could run the helpers.py file, and you can see that the first result is false and then the second one is true. So this means that the function is actually working great. Okay, so now we can continue on writing a function that is probably going to say something like def calculate primes, like that. And as I said in the beginning of this example, I'm going to receive here start and finish, so we will know the range of the numbers that we should check. Okay, so inside here we could open a new list, and we could say primes equals to an empty list, and we could start an iteration like the following. So for n in range, and we could start and finish like that. So this will be an iteration throughout all the integers between 1 to 100 in the future. And then we could say if is prime n, like that, then we could append this to our list like that. So primes dot append n, and then we could return primes like that. Okay, so once we have completed this, then it is a great idea to go back to our run.py and see how we can import each function from the helpers.py. So we could basically say import helpers like that. Now the reason that I can do this, it is because the run.py and the helpers.py are in the same directory, so it is very okay to go with this approach. Okay, so now, as you can see, we still got this error in here because we probably want to say helpers dot like that, and then the error will be fixed. Now you could also use the wildcard import in here. So if I press undo for a minute and go and change this line to something like from helpers import everything like that, then you can see that the error is disappearing as well, because now you don't really have to refer to the file's name, and that is perfect. Now if I run this program, so I will say run.py, and then you can see that we receive a list of all the numbers that are prime numbers. Now here's the real deal, where the constants.py could be actually very useful. Now let's say that you want to play around with this program a little bit, and you want to skip all the numbers between 20 to 50. And you probably look for a way where you should implement the logic of that. Okay, so basically it means that in helpers.py we should go to our calculate primes, and we probably want to write here some more conditional that is going to be responsible to skip the numbers that are between 20 to 50. So to do this, we could basically add one more constant in our constants.py, and we could say here skip underscore range, and that will be equal to range of numbers between 20 to 50 like that. And then we could go to our helpers.py and write here some more conditional that is going to say and here we want to check if the iterated number is between 20 to 50. So we could go up here and we could import this from the constants. So we could say in here import constants, as C like we did with the run.py, and then I will go back to our conditional and we could say and n not inside the c.skip range. Okay, so you see, whenever you want to implement some logic and you want to create some variable for it, and this is not going to change throughout the execution of the program, then it is a perfect idea to put all this information inside a file that you can name it variables, constants, or something that you can really understand in the future, that this file includes all the information about storing some variables. And once I have added this functionality inside this if statement, then if I go ahead inside our run.py and really execute run.py, then you can see that the program has been changed, and after 19 we directly see 53 and we don't see 21 or something that is really a prime number in the range of the skip range. So this could be one example how you want to divide your project. You could basically store all your information in a one file and your functions in another file, and then there will be one more file like run.py that will trigger and collect everything and will execute the stuff that you want to execute. Alright, so now that we understood the purpose behind each file in such a project, now let's assume that we want to take this project one step further, and let's assume that we want to send a nice email about the results of an execution of such a program. Now, what this will mean? This will mean that we probably will have to go ahead inside our helpers.py and put in some additional functions that will be responsible to send email to someone that we decide. But doing such a task is something that is quite complex, and we might want to avoid creating those functions inside the already existing helpers.py. Because if you remember, our helpers.py is only including some functions that are dealing with operations around prime numbers. So maybe locating email actions inside that file could be something not nice and not organized. And in that case, we might consider creating a separated folder for all the actions that are going to deal with all the actions that are necessary to send an email. So in that case, it is a great idea to restructure your project and make it to perform like Python packages. Now, Python packages will allow you to store your entire functionality inside a directory, and then you can import its functionalities and its classes by basically referring to that folder name. So let me show you a template of how this project should be structured if we want to add some functionality like sending an email. Okay, so I'm back to the terminal for a minute, and in here you could pay attention that I'm located inside a directory that is named structure2, unlike before where I was located inside structure1. So if I'm going to hit here the 3, then you can see the division of the files and folders in here. So you could see that now we got directories email and prime calculation, and then outside of everything we have our run.py. Now you could also see that in each directories I still have the files that says constants and helpers, and as well as in the prime calculations. But you could also pay attention that I included a file that is saying dunder init.py. Now normally when you want to divide your project into Python packages, you have to create a convention file that its name is _init, and if it doesn't make sense for you right now, then I will show an example of that just in a minute, because I'm going to restructure our project and make it to support such a template. So let's go ahead and see how this could be implemented with the project that we already started to work on. Okay, so to really create the imagination of how this program is going to look like when we restructure it from scratch, then I'm going to write in some functions for the actions that I'd like to take in general. Now I know that those functions are not created yet, so we might receive some errors. Okay, so at first, we still want to calculate the primes, but you probably want to avoid sending an email with only a list of numbers, so we probably look for a way to prettify the results that we received. Maybe we want to display this separated line by line or stuff like that. So the next step will be actually to go with something like the following. So this could be something like primes.prettify, and I could imagine that this method is going to grab all the numbers and is going to split each number in a separated line or something like that. And once I have done that, then we could assign this to a variable, for example, like prettier, and this is going to be equal to that. And again, everything that I'm doing here is just an imagination, and I did not create any of those methods and functions yet. So now we could imagine that we import a class that is going to deal with all the functionalities how we should send an email. So this could be something like email equals to a new instance of an email, and now we could override some properties to really customize this email. And those things could be attributes like to, body, subject, and stuff that is dealing with email sending. So this could be email.to equals to, let's say, johndoe@email.com, like that. And we could say email.subject equals to prime numbers execution between, and we could refer to c.start, like that, to, and then we could call this curly brackets, and we could say c.finish, and we should turn this into a formatted string, like that. And we could say further than that, email.body equals to prettier, because if you remember, we simulated a method that says prettify that is going to be responsible to really grab the list of prime numbers and turn them to a nicer output. Okay, so at the end, this might be something like email.send, and this should be enough to really perform all the actions that we want to perform per each execution. Okay, so let's actually go ahead and see how this could be implemented in the new structure that I talked about. So first, I want to show you how you can create a new Python package and why we should include the dunder init file in each Python project. So now I will go and create a new directory inside this project, and we could name it email, like that. And inside this email, first we are going to create the dunder init file like the following. And as I created that, I will allow myself to close this temporarily, and I will continue on, and I will create here another file that says email, like that. And in here we are going to include a class that is going to perform some email sending actions, and we might also include some helpers file in here, although I don't know if we are going to use that much. But this is just to make you understand that if you want to add some complex functionalities to the email package that you are including in your project, then it is something that is quite possible by maintaining constants for each of your package. Okay, so now that I created those, I will close and I will explain why we created the dunder init file. Now, since we created that dunder init file, then the Python is going to recognize this as a package in the directory of the entire project. So this means that you can refer to this email directory like a package that you already worked with. So if you already know, then you have a lot of packages in Python, and the basic way that you refer to them is by using import, like that. Now, by creating the dunder init file inside the directory, you could basically refer to that by only saying import email, and this will already recognize it because you have included the dunder init file. Now, if I was to delete the dunder init file from here, so I will actually do that, then the second that I have done this, then I don't have access to the inner files inside this directory. But if I was to bring back the file, so we will create that again, like this, and then I will go back to our run.py. Then the second that I'm going to hit the dot sign, then you can see that there is already an auto-completion of the files that are included within this directory. So this means that it is being recognized as a package, and this is quite critical for us. So now we really have access to everything within this directory. So we could import every file from here like that. And we could also import email.constants, and we could import email.helpers and so on. So it is very important to realize that. Okay, so to continue on with our program, then I'm going to create a class that we will name it email, and I will do that inside the email Python file, which is under our email directory. Now I will go ahead and easily say class email, and I will type in pass temporarily. Okay, so I'm back inside our run.py, and in here we want to import the class that we have just created inside the email.py. But before we do this, I realized that the variable name in here is quite forbidden, because now the Python is going to be confused how to refer to the email package, because there is a variable that we named email. So to avoid such a confusion, we could basically use the refactor rename functionality of PyCharm, and we could rename this variable. So we could basically change this to something like new mail, like that, and this should be good enough to continue from here. And now I will go up top here and I will import the email class as a package. So this could be by easily saying email dot email import email capitalized, and this should be really good. And as you can see, the error from here is disappeared. But now you can realize that there is an error that says us there is no method named send recognized inside the email class. And that is perfectly making sense, because inside the email class we don't have anything defined. So just to avoid such an error, we could say here def send, and we could only print here something like email has been sent. Now, as you could realize, we are not really going to send an email to someone, but only I wanted to show you how you can package such a complex functionality, and you could already do your comparisons with your own projects, how you can package stuff and really maintain more organized code. So now that I have done this, then if I go back to our run.py, then you can see that all the errors have been disappeared. Okay, so now that we understood how we can create a package for a specific area that we want to function, then let's go ahead and see how we could do this for calculating the prime numbers in a given range of numbers. So to really collect everything that is related to that, we could go and create one more directory inside our entire project. And we could name it something like prime, and then we could move everything that is related to the prime calculation under this directory. So we would go and move those like that, and we will click on refactor, and we could do the same thing for the helpers.py, and we will click on refactor as well. Now the second that I have done this, then you could pay attention how the second line in here has changed. Now you might not have remembered this, but this was actually used to be like that, but since it is moved under the prime directory, then it went ahead and actually changed this line for us. So this is what the refactor is about. And let's actually create the init file in here, so Python could really understand that this is a package. So it will be dunder init dunder like that. And the second that I have done this, then I can close this file and I could change this import line to being like an import from a package that we have already done in the email package. So we could say import prime.constants as C like that. And you can see now that the line in here that is referring to that C variable is not having any error, and you can see that this error is also fine because we have created the dunder init file. So now that we have done this in here, then we can close those files, and you could see that the primes is still referring to a calculate primes function. Now it could have been a lot nicer if we would have changed this into a class and then take some different actions within that class by referring to the instance methods. So to do this, basically I'm going to do the same things that I have done with the email package, and I'm going to create one more file just as the same name as the package. So I will name a new Python file prime like that, and I will zoom in a little bit and I will say class prime, And inside our constructor we can receive the following parameters. So it could be start and finish like that, and we could initialize those by saying self.start and as well as self.finish equals to finish like that. And now that I have done this, then we could create a method that its name would be calculate primes, and we could basically copy the exact same function like we have written inside our helpers.py. So to really avoid confusions in here, I'm going to open the helpers.py and I'm going to split the panes so you could see better. Okay, so in the right pane I'm going to have the helpers.py that is inside the prime directory, and in here I'm going to have the prime file itself. So now I will allow myself to copy this from here and paste this in under this method. And now we should take some actions to really get rid of those errors, and we could change this to self.start like that, and we could change this to self.finish. And as you can see, we still have some errors with isPrime. So to get rid of this error, then we can import everything from the helpers.py. So we could say from prime.helpers import everything like that. And as I have done this, then this error is disappearing from here. And now we can remove this entire function in here because we already maintain it inside our prime.py, and for sure we don't want to have duplicated code. And I could also delete the prime.constants import in here as I don't really use it in here, and we should only leave the isPrime in the helpers.py. So now I could close this and go back to that file, and this file should also import the constants because we are referring to that skip range constant. So we could say in here import prime.constants as C like that, and this error should disappear as well. And we could jump 2 lines in here just to follow Python conventions, and I think that the prime.py file is pretty much ready. So now that we have done with the customization of that, then we can close this out, and we can also close the helpers file, and you can now guess that the run.py file is going to have some errors because we deleted this function and this file does not understand where the C variable is coming from. So to fix that out, then I'm going to import the class that we have created like we have done for the email. So I'm going to change that to from prime.prime import prime capitalized because we are only referring to the class that we want to initialize. And now that I have done this, then we could delete this line and we could say p equals to prime, and now to initialize this successfully we have to refer to the constants. So we could import the constants like that. So we could say import prime.constants as C like that. And as I have done that, then I can pass in as the arguments of that instance start equals to C.start, and we could say finish equals to C.finish. And now that I have done this, then I could print the calculation of all the prime numbers in the given range of numbers. So we could say p dot calculate primes. And now that I have done this, then you can guess that we want to receive the calculated primes in a lot prettier way because we simulated that by creating the prettify method. So I will delete that, and now we should imagine something like prettier equals to p dot prettify like that. And now you can guess that this receives an error, so we are going to fix that by adding a prettier way to display the prime numbers in a given range of numbers. So I'm going to go inside our prime.py and I'm going to create here the method which is going to say def prettier, and this is going to receive self as an argument, as a parameter, excuse me. And I am going to say here something like the following. So let's say that we want to split the results into different lines. So what that means? It means that we want to print a prime number in its own line. So we could basically iterate over the results and we could say something like that. So I'm going to type in here for result in self.calculate primes. So each time that I'm iterating over the calculate primes method, then I probably want to insert it inside a big string that is going to be written with a multiple lines. So I can say body equals to nothing like that, and then each time I iterate over the results, I can fill in the string. So we could say something like body plus equals. Then we could refer to a formatted string and we could say this is a prime number, and we could refer to that prime number by saying result, and we want to escape the \n so that in each iteration we will have a line that is being jumped to the next line, and you can do that with the \n. And now as I have completed this, then I can get out of my for loop and I can return that body, so we could really have the chance to see the results in a prettier way. And now, just to show you how this is going to look like, let's go back to our run.py, and I'm going to... I just realized that its name should be prettify, so excuse me about that. And I will go back to here and the error is disappeared. Okay, so just to show you the result of that, then I'm going to simply print the prettier, so we will say print prettier like that. And now we are ready and good to go to execute this program. So now if we execute this program, let's see the result of that. So you can see that we start the iteration over the prime numbers and we see that we have a nice output for each of the prime numbers in the given range of numbers. And you can also see that we have the email has been sent line that is arriving from the send method that we have initialized from the email package, which is happen to be under the email.py file. And that is perfect because now we have everything at its own place, and this is a really basic example of how a Python project should look like. And this is very important to realize that if you have different functionalities that are quite complex, then maybe it is worth to separate those into different packages. So later when you go ahead and you want to take only several actions within that specific area, then you can already know how to refer to that because it is located inside an organized package. Alright everyone, so let me know how you did with this video, because I know that we have covered a lot of information and maybe some of the points are not quite making sense for now, but you will see that if you want to develop some large project, then packaging stuff within directories and creating this .init file in each directory will going to help you a lot, and it will also help you to make your code look a lot nicer and friendly. So if you want to come with a larger projects that are going to be successful and also have maintainable code, then I will go with the following approach for sure. Okay, so if you like this video, please hit the thumbs up button, it is very important to me, and consider subscribing to my channel if you already did not, and I will see you in my future uploads.